Good day, everyone. We're going to start off with what's new with Stratasys. As Tim mentioned, I've been doing 3D printing for 30 years now. I'm one of the first pioneers back in the days of DOS. That was quite painful. But let's look at some of the new stuff that's out there because it's really gotten a lot easier, a lot better. And we're going to look at FDM Technology. We're going to look at the PolyJet Technology and the new stereolithography technology that Stratasys is introducing. Stereolithography is not new, but it's going to be new to Stratasys. We're going to look at all three of those. Starting off with the FDM, which is fused deposition modeling. Most people are familiar with it because it's the most common out there with all the hobbyist type machines. Of course, the difference on Stratasys machines is that they use two print heads and a support material that will dissolve away, making it much easier to build parts. What they've added to the FDM now is the F120 series. The F120 added to the F123 series. This is an industrial desktop model, and it's based on the F123. In fact, it uses the same platform as the F170, so the trays are pretty much interchangeable. They're the same size. The only difference is this is a desktop model. You don't need any specialized training. You don't need a dedicated technician for this. And it's very intuitive in the GrabCAD print software. We're going to talk more about GrabCAD software. It runs a build volume of 10 by 10 by 10. Currently, there's two materials available, the ABS and the ASA. For those that are not familiar with ASA, that's a material that's similar to ABS, but it's got UV resistant properties. It's got an application where it's going to be outdoors, or if you want to see brighter colors in there right now, only white and black, but the ASA is a good choice. It has a soluble support material, and we build it in layers of 7, 10, and 13 thousandths of an inch. You'll notice in the picture, the two boxes on the bottom down there, those are the print material. There's 200 cubic inches in there, and you can actually print for 250 hours continuously. So it's not like the other machines that only have 100 cubic inches or less, sometimes 60 in there. You can end up having to swap materials out. Here, you're going to get a lot more runs. So it's more office friendly. People don't have to change materials out nearly as often. Looking at GrabCAD print software and some of the changes they've done, I should mention that GrabCAD print is free software out there to download. You don't have to own a Stratasys machine to view and estimate files with GrabCAD print. So it's free out there. You can use your CAD files, you can use STL files, so it'll take native files as well. What they've changed in here on the GrabCAD printer, what they've added, you can see up here where they have put in different support icons so you can see what you're getting for your fill inside. But though they've really changed it, you can change your infill density here. If you want to make that wider or smaller, you could do that. Also, the body thickness has been changed on here. You can add more body thickness. What that means is the perimeter or the border, if you decide you want your part to have 1/8 of an inch thickness and still be hollow inside, you could change that to 0.12, 1/8 of an inch. You can also change the infill angle on there. Currently 45 is the default. It works well, but it is allowing you to change that. So lots of new things with GrabCAD print. PolyJet Technology. It's a 3D printer, works real similar to your inkjet printing head that you have on your home. The only difference is you don't have Z-axis on your home printer. Here you've got a Z-axis. What's really changed on PolyJet here is that they have a breakthrough. This is a milestone in 3D printing. Stratasys J750 and the J735 are the first printers with the ability to print color quality validated by Pantone. Pantone is the industry leader defining standards that communicate consistent colors across many industries. So the Pantone colors here are key to getting quality, realistic looking parts. And in the GradCAD print software, you can easily select almost 2,000 printable colors here. You can select it either by the number, if you know the number, or you can pick the range sliding up and down the slide bar in there. So you're going to get good quality models. Now another thing I've added is the Agilus 30 white. We've had Agilus 30 black and Agilus 30 clear for quite a while. Those are our stretching materials, rubber-like materials, flexible. And now you can take the white and you can add colors to it. However, I will tell you that the more color you add, the stiffer it will be, because you're taking away less of the Agilus flexible material. Therefore, the more pastel your color looks, the softer it's going to be. So you can either pick a color, you get a little flexibility there, or you can actually pick the shore value and it'll tell you what color it's going to blend and be there. So there you can see a range of softer, will be the lighter colors, and as they get darker, those will be a little stiffer. Stereolithography. Stereolithography has been around for 30 years. It's actually the first 3D printing patent that was out there. In fact, the word stereolithography was invented in 1984 for the patent. It actually comes from three Greek words: stereos, meaning three-dimensional. I know a lot of millennials think that stereo means two speakers. It actually means three-dimensional. And lithos is hard or solid, and graphos is printing or writing. So it literally means three-dimensional solid printing. That's where the whole 3D printing industry started. Again, it's been around for 30 years. It's been accepted for a wide range of applications. So Stratasys is now introducing stereolithography machine. Just to give you an idea of how stereolithography works, also called SL, it starts with a UV laser. The UV laser shoots out an ultraviolet light, goes through an optics filter, and that separates 355 nanometers in there. Now, once you separate it, it has a scanning galvanometer. That really is just a servo motor with a mirror on it that is going to position and focus and move that beam that's focused on the surface of the resin in the vat. Now, the platform goes up and down in the z-axis. The scanning mirrors take care of the x and y, and your z-axis is taken care of by the platform. And it hardens each layer one at a time on the top until you build the entire part, and it repeats the process. So we're introducing the Stratasys V650 Flex. The V stands for vat polymerization. That's a designation from the ASTM F42 standard that defines additive manufacturing technologies. Flex refers to flexible for an open source material. You can run any resin you want in this as long as it will cure at 355 nanometers. Therefore, you could develop your own material if you wanted to. So it's got a large build volume, 20 by 20 by 23. This is going to really help for the production type parts. You can get down to 4,000 build layers. You can build greater than that, but 4,000 is typically what you get down to. The beam size is adjustable for fine detail, or for big parts, you can go up to the 30,000s. And it's got a fast draw speed of 700 inches per second. Again, on the vat system, the customer can use any resin they want. But we're starting off with 4 profiles or set of parameters of DSM resins that are commercially available. DSM Somos has been in the business for many, many years, making stereolithography resins, recognized as a leader in the industry. You also have interchangeable vats, full, quarter, or half vats. And the reason this is important to you is not everybody builds parts 23 inches deep. So if your parts are only 9.5 inches tall, you may want to consider a half vat so you don't have as much investment material, the liquid material, in the vat itself. There you've got some choices on your vat size. It's built for 24-hour, 7-day operation. This has been tested at Stratasys Direct, service bureau that Stratasys has, and they've been using it for over 4 years now. They've been using 24 hours, 7 days a week operation out there. High reliability. It's a very simplified design. One of the problems with stereolithography from the foreign market out there, there's a lot of them out there, is getting parts and getting reliability issues. Here we're going to be coupled with the support infrastructure that Stratasys already has, and we're going to couple with a world-class resin supplier with DSM Somos. So that's going to help our reliability considerably. Your site requirements, it's got a smaller footprint than the competition out there. It doesn't require anything special. You can run on 110 or 220 out there single phase. It's got some smart controls built into it so that it allows the printer to operate for a short time. It's also got records the build layer it's on, so if you've got a power outage that lasts longer than the UPS backup, you can actually restart the job when you get power restored. That's a key function when you're building big parts. It also has the integration for a database, so you can interface, communicate in database for your monitoring. Lots of companies out there that want to monitor, to do SQL language in there. They also want to do statistical process control. This monitoring allows you to do that. Let's talk a little bit about the materials, just so you can know the difference between photopolymer materials and engineered plastics. When you're running with FDM materials, your FDM materials are softening plastics. ABS, your nylon, all those engineered materials out there, they become pliable and moldable in injection molding. Think of it like a chocolate bar. You can melt that and form it and remelt it and form it and melt it and reform it all day long. Now your photopolymers, they're a thermoset material, not a thermoplastic, but a thermoset. Once that liquid is kicked off, think about like a two-part epoxy. Once that material is kicked off, you cannot put it back into a liquid form. Cured, and I've got an example down there, it's crackers and some flour. You mix that flour with other ingredients, but you'll never be able to pull it back out and get it back to its shape where you can make crackers again. So anyway, so it's a thermoset material. It can be burned out under high heat, but it will not melt. So the four materials we're looking at with DSM Somos is Somos Watershed XC. That is a rigid, clear material that has been used for well over 10 years. And it's the most popular general purpose material on the market due to its clarity and its water resistance. So this is one of the key general purpose materials out there. The next one is a Somos Next material. This is a tough, durable impact. You can bounce it on the floor without breaking it. It's really tough, and it's for general use parts. But both of these will work well for the majority of parts. The high impact, the Next is great if you want the clarity, and of course the Watershed. Now, Somos also makes resins for particular applications. They have specialty resins. Now let's look at a couple of those. The Somos Element. This is strictly for investment casting industry. It has no heavy metals, antimony in it, in particular, and no heavy metals. Those can contaminate your castings when they pour the metal in, if there's any left in there. Also, it has low ash during the burnout cycle. But remember, when you're making a lost wax or investment casting application, you've got to melt this pattern out of the ceramic shell that you put around it and then pour the metal in. You can't melt this out, so you burn it out. It comes out about 1800 degrees Fahrenheit, which is well above the temperature that you use to pour your aluminum or steel. And then Somos performed down there. It's a ceramic composite, very high temperature resistant. So this is really great for plastic injection molds or even under the hood automotive uses. Also, if you're going to plate, if you were going to nickel plate or chrome plate your parts, this is a great material to do that. And the reason is because it's ceramic, it has very little coefficient of thermal expansion. What happens when you plate parts that are 3D printed usually is you may put them under the hood, they'll be chromed, and as your hood warms up, that plastic stretches. As it cools down, it contracts. Well, that plating does not contract and stretch the same rate. So therefore, it is going to end up flaking off of there. With a low expansion rate on this, this is one of the better materials, really, if you're going to do plating or automotive parts, things like that. I've used it for that. DSN has over 20 different materials available for general purpose use out there for specialty applications. So these are just the first four we're starting with. They offer a lot more. Somos will work with you, Stratasys will work with you. We will work with you on getting parameters for any other specialty materials you might need out there. And that pretty much covers everything that we want to talk about as far as the three technologies and what's really coming out new. If you want more information, I would recommend our website. We have daily blogs out there. We print sometimes 2 a day, but they're always going to be on either 3D printing or SolidWorks or some technology out there. We've got monthly webinars we do. We have a newsletter that you can subscribe to at the CATI website, and we have video content. And this will be on our YouTube channel also. We have video content out there that you can look at some of the past webinars. And that's really all I have, so let's open it up for some questions and things like that.
All right, thank you, Mark. If anybody has any questions, feel free to throw them into the chat.
Hopefully we covered everything and we don't have any.
All right, it doesn't look like we have any questions coming in, so thank you everybody for attending, and check our schedule on the website for more webcasts coming up.
All right. Thank you, guys.